Welcome friends. In today's video, we are going to see one of the important concept for seed interfaces in Java. So let's understand this with first. Let's understand what is seed interfaces. Then we are going to see one of the coding example as well. So first, we will see seed interfaces. Then we will see what is non-seed interfaces in Java and the importance of this and where we can use and what is the use cases when we are going to use these interfaces. So let's understand with this definition first. Seed interfaces in Java introduced in JDK 15 as a preview feature. Means it is launched in 15 itself, but it's stabilized in JDK 17. Provide a way to restrict which class can implement an interface or extend a class. Means which class we can implement or extend the class that it can define by seed interfaces. This feature is useful in various scenarios where you want to have control and fix hierarchy. Let's understand here. I have created one main method class and in which I have created one payment method interface. So this payment method interface is a seed interface payment method. It permits credit card payment, bank transfer, and digital wallet payments. So these classes can extend this payment method interfaces. So we are going to see how we can process this. Let's understand further. And key point here is sealed classes and interface. This restrict which classes or interfaces can extend or implement them. Means that class which we can restrict uh, or interfaces can extend or implement them. Then non-seed classes, this allows, here if we see, this is the, in Java, the non-seed keyword is used in conjunction with seed classes and interfaces. When a class or interface is marked non-seed, it indicates that this class or interfaces can be further extended or implemented by any other class or interface, effectively lifting the restriction imposed by the seed parent. Means non-seed is we can use in conjunction with seed classes and interfaces. When class or interface is marked non-seed, it indicates that this class or interfaces can be further extended or implemented by other subclasses. Let's understand these use cases for seed interfaces. When designing a framework library, you might want to restrict which classes or interfaces can extend your base interface. This ensures that only a limited set of known implementation can be created, preventing misuse or incorrect in extensions. Means, for example, in financial application, you might have transaction interface with only specific type of transaction allowed by deposit and withdrawal. So we can restrict this transaction as we are creating a transaction interface as a seed interface and provide permits to this deposit and withdraw. Then enhanced security, it will provide us by sealing a class or interface. You can enhance security by ensuring that only trusted classes within your code base can extend or class or implement an interface. Means trusted classes which we have permitted that only can implement these interfaces. Example here is in security framework, you might have credentials interface that should only be implemented by specific types like password credential or token credential. So we can create credential as our seed class or interface, and then we will provide permits this password and credential token credential classes. Here, if we see in pattern matching use case, when using pattern matching, example instance of switch expression seed interfaces ensure that the compiler knows all possible subclasses. This allows the compiler to enforce exhaustive checks, improving code safety and reducing runtime. So example here is in shape drawing application, you might have shape interface with known types like circle, square, and triangle. This allow for exhausting pattern matching when performing operation on shapes. Let's understand this with example. Here I have created one payment method, which is we have process payment implementation method. We need to provide implementation for this method. If here we see in our three subclasses in bank transfer, here I have created bank transfer class, which is implementing payment interface. So this is the final class. Because we cannot extend this as it is only permitted by payment methods. So what this contains: bank account number and bank name, and we are going to processing bank transfer payment with the help of process method and amount and bank number. Let's understand another digital payment wallet class is there. Bank transfer we have seen just, and we will see credit card payment interface class. This is also final class, which is extending payment method. It is having string card number and card holder name, and we are creating constructor here and overriding process method of the payment method interface. So it will process credit card payment or amount and card holder details. Yes, card holder name, which we are giving card holder name. Then next our class is digital wallet payment, which is containing wallet ID and wallet provider. Here constructor we have created, and we are processing digital wallet payment of amount and wallet provider details. Let's see our main code here, main payment example code. If we see, we have created payment interface reference, and we are calling that process payment method here, passing card details. Card details I have passed here. Suppose card number is this and name is this. Then bank account number for bank transfer payment. So this is the required parameter we are using in our these classes, and we are passing as a constructor to this. Then bank name, national bank, and wallet, digital wallet payment, wallet 123, wallet provider, PayPal. So let's pass some amount to this credit card, bank transfer, and digital wallet payment. So this is implementing from our parent payment method interface. Let's run this and we will see. And here we see non-seed keyword is used to in conjunction with seed classes and interfaces. When class or interface is marked as non-seed, it indicates that this class or interface can be further extended or implemented by other class or interface, effectively lifting the restriction imposed by seed parent. Means if we do some restriction on the classes or interfaces, that we can impose that with the non-seed classes. Your use cases for non-seed is: imagine a scenario where you have a hierarchy of classes or interfaces where most subclasses should be restricted, but one particular subclass should follow further extension. This is where the non-seed keyword is used. Means any classes want further extension, in that case we can use a non-seed classes. Let's see our example. Our code compiled with fine. So here we are making processing credit card payment with 150 and card holder name is Alex Johnson. Then processing bank transfer payment 250 to Bank National Bank. Then processing digital wallet payment 75 using PayPal. So this is the basic example of the seed classes and interfaces. I will come up with a few more advanced details with this. So subscribe to the channel, guys. If you like the content of the video, subscribe and like videos. Thanks for watching this.